Good afternoon. My name's Kevin Main, and I'm with Mote Marine Laboratory in Sarasota, Florida. And I really don't think it's fair that I should have to come after Barton, because that was, I'd much rather have had some other spot in the program, but I will do my best to give you a presentation that covers the topic that I've been asked to address. Some of my colleagues have already talked about the issues. That's what happens when you come a little bit later in the program, but that's okay. I think that these issues are critical to discuss and ones that we need to be thinking about. And let's talk about fish, because that's our section here. And if we look at fish, we know that it is, in many parts of the world, the primary protein source. For nearly 1 billion people, that's where they're getting the majority of their protein. And we know that global seafood consumption has increased over time, from 9 kilos back in '61 per person. Now we're up to 17 kilos per person in 2008. And as was discussed this morning, seafood is a high protein food. It's low in calories and fat. It's definitely a better thing to be eating. That's what Cynthia was talking about just a little earlier this afternoon. It's high in vitamins. It has wonderful health benefits. We need to be eating more seafood. So that is an important area that we want to stay focused on. The key thing that is certainly coming and on the horizon is that there are going to be shortages in food and especially water, and that those shortages in water are going to constrain growth in terrestrial agriculture and in freshwater aquaculture, which is causing many areas where they've already started to realize that, especially in developed countries, to look at a shift from water use to recirculating water so that we can clean that water up and produce the food that we need. Now, the only food source where we still are collecting a lot of product is from the wild is seafood. So we do see that there is still a fair amount of product coming in from wild rather than farmed. And so in order to increase our global food security and provide that safe, nutritious, high-quality seafood, and to restore declining fisheries, stock enhancement is certainly something that's accomplished by hatchery production or aquaculture. We need to do all of those things, but we need to do that with a limited impact on the environment. We want to have limited impacts on our land, we want to have limited impacts on water, and we want to have limited impacts on fisheries, so we want it all. And, back in, I think up until the 90s, we still were believing that we were going to be able to get the majority of the seafood that we were going to eat from the oceans. But it was really clear that we had started to exceed that maximum sustainable yield. And sure enough, when we look at the statistics, I'll only show this very briefly because Cynthia already showed this same set of data. This is just looking at a little window of time over the last 10 years, but you can see that capture fisheries has been static. In fact, it's been static for over 25 years. And then more recently, since 1990, we've seen aquaculture come in to take up a bigger and bigger portion of that. Right now, it's just under 50% of our seafood production. And it is primarily being produced in Southeast Asia, with China being the king. 62% of the seafood produced in aquaculture is coming from China, and another 28% is coming from Southeast Asia. So that's Vietnam, Indonesia, the Philippines, and other countries. So over 90% of the seafood that is being produced in Asia. Now the U.S., where are we? Frankly, we're nowhere. I mean, the U.S. currently has a huge trade deficit, over $10 billion in seafood. It's the second largest trade deficit, right behind oil and gas truly, it's a food security issue here that we are not producing the seafood that we're eating. In fact, the latest numbers, and I heard Barton say this, 91% of our seafood is imported. That's the 2011 numbers, and 50% of that is farmed. With U.S. providing only 5% of that seafood, we know that there's a lot of product coming in, and that U.S. produced seafood is some of the safest, most heavily regulated product. And so what we really need to be doing is increasing production of seafood in an environmentally sustainable way. So I'd like to switch now and talk a little bit about the way that seafood's being produced, the shifts in where it's going, and what we need to do in order to get production up and running. So there are a variety of different systems that are used to produce seafood around the world: ponds, cages, flow-through systems, recirculating systems. Let's touch first on ponds. This is the most common way that seafood's produced around the world. China, Japan, Hawaii, Czech Republic, we see ponds all over the world being used to produce a whole range of different products. The impact from pond aquaculture can be substantial if they're constructed in wetland habitats. We've talked about that already. If they're stocked too heavily and that water has to be discharged into rivers, lakes, and oceans, and those areas have poor circulation, then you're going to have environmental impacts. And if they allow exotics to escape, so there can be impacts associated with pond aquaculture. All of it isn't bad, but there can be. Nearshore Cage Systems. This is a cage set up in, where's my pointer? It's somewhere here, Japan. Here's some in Norway. If the cages are put in the wrong environment, if they're too dense, if the exotics escape, if there's too many and disease occurs, you can have environmental impacts. So certainly there can be negatives associated with nearshore cage production systems. Not all are bad, but there certainly are a whole litany of examples where there have been problems. Then we have open flow-through tank production systems. If fish are being grown inside tanks, it reduces some of the impacts. If that water then is discharged, if it's flow-through, water in, water out, if it's discharged back into lakes and coastal habitats, that concentrated effluent can have environmental impact. That's why we need regulations. That's why we need to be looking carefully at where the water is being put out. There can be escape of exotics. Large water volumes are required when you have a flow-through system. So all of those are issues associated with a variety of different production systems. Okay, so then we move on to the new directions. What are people doing that is different in aquaculture? Well, they're trying to get away from many of the nearshore cage problems by moving cage systems out into deep water. And it's called offshore aquaculture. It requires very deep water, 100 to 150 feet minimum, in order to put those cages out there. It's expanding all over the world. China has thousands of offshore aquaculture cages in place. In Europe, they're putting them into place. In South America, we're seeing this industry grow. And the reason that they've done this is because they need to get away. We know we need more food production, and they need to get away from those coastal systems. And what happened is when they sited too many cages in the wrong environments, they had losses, and that's not what farmers want to do. And so they have moved into offshore systems. There's been a lot of technological development on these cages, a lot of cool designs. Here's some scuba divers on one of these huge cages off the island of Hawaii. And so there's a lot of interest in this, and we know that these systems can produce large volumes of fish. The key will be to look at the parameters that we need in order to produce the seafood in these systems with limited environmental impact. There will be impact, there's no doubt about it. But if they are sited in the proper locations, in the proper densities, then we can have a seafood resource and begin production. And I certainly hope that we're going to do some of it here in the United States. We aren't currently, except for a small effort in Hawaii, and then some experimental work that's been done in other areas, in the Gulf, in Puerto Rico, in New Hampshire. But currently, we have just not moved ahead like other areas have. Now, there is some permitting structure that's being developed within NOAA because NOAA knows that we need to move in this direction. And so there's movement to do that. I hope we're going to be involved in the production efforts. This is the area that I work in. I'm a firm believer that recirculating aquaculture systems, land-based systems, are going to play a bigger and bigger role as time goes on. They certainly are playing a much bigger role today in European aquaculture production than they were in the past, and we're seeing a number of facilities expanding here in the United States. The proof is in the long-term sustainability and economics associated with those systems. The technology is relatively new, 10, 12 years of intensive work on this effort in areas where people have been willing to pay more for a high-quality product produced in these systems. We've been able to make it work economically. There are some real advantages to these systems. They conserve water resources. They recycle it and reuse it by reducing the environmental impact. They also can provide a consistent water environment, which will allow you to grow those animals to production size faster. And then they can recycle and treat the wastewater and bring it back into the system and maybe even develop a secondary product. And this is the new movement. These integrated systems are multi-trophic aquaculture systems. It's kind of a return to the past because the Chinese 5,000 years ago were doing this type of aquaculture, but in very low densities in their backyards where they were producing a variety of different products using these integrated systems. We got away from it and got into single production systems. Now people are going back to it. It's kind of exciting. And so we're seeing that movement go on and improved engineering and production of these multiple crops. Another thing that can help to improve the bottom line is the incorporation of alternative energy. We really need to get that incorporated into these systems, and there are places that are starting to do that today. So this is the facility that I work at in Florida, Mote Aquaculture Research Park. We have a commercial farm where we're producing sturgeon and caviar. And we also have a big research unit here where we're working on a wide range of marine species. And just so that I can give the short 101 course in recirculating systems, here's where the fish are growing, right here in the systems. And then the water, the waste and the water is going to move through a whole series of filters. And when it's done, it's going to come back. The water will come back. The waste is removed back into the fish system. And so you can do that with a variety of different mechanical or animal processes in order to clean that system up and get it back into, clean that water up and get it back into the system. And so integrated systems, I mentioned this a minute ago, is where you're producing plants with the waste coming out of these filter systems. You remove the solids out of the water stream and use it as fertilizer. It's a nice, good source of fertilizer. Just have to go through the process of separating it and then use the water to move it through plants for either food or habitat restoration. And here is a project that we're working on at my facility where we are producing a wide range of coastal plants in the wastewater coming from marine fish production units. And so mangroves, salt marsh grasses, a whole range of different things that can have a secondary income stream associated with them and do another job for us. Okay, so let's talk about seafood. Let's safe seafood. That's something that we're very concerned about. And so,
how do they sterilize the water?
how? Either ultraviolet light or ultraviolet light and ozone. So you can use both of those as a sterilization. Depends on what you need. Usually it's UV. Okay, so if we look at safe seafood, which is something I'm concerned about, with 91% of the seafood being imported and less than 3% being inspected, let's be sure that we're getting a good product here. So let's say, what are we trying to do? What are we talking about in terms of safety? Are we talking about safety for this little guy right here, or how about for pregnant women? I should add that picture in there. I need one of those. And safe for what? You know, safe for the environment, safe for the earth, safe to eat. And so those are the things that we're looking for. We're looking for a high protein food source with limited impact on the environment. So in recirculating systems or in any kind of water system, we need to have a surety that that product is being produced in good water. And so I'm going to focus first on land-based, or actually exclusively now on land-based systems, because in recirculating systems, you're taking water and you're moving it through those filter systems and back in there. So let's talk about what we're going to do to make sure that that water is safe. First, for the incoming water, the water that we're bringing into the fish system, got to make sure that it's good to start with. And then the water within the tanks or the ponds where you're growing the fish, and then the water that's leaving. And so, water quality standards have been established for the water that's coming into those systems. And it may require pre-filtration. And the first thing that you need to do is test that water and make sure that the water resource, suppose it's a freshwater well that you're putting in, you got to make sure that you're using a high quality water that you're bringing in there, not something that's been contaminated. And then the other thing that we always recommend to people is that you do a bioassay with the fish that you're going to grow in the system. Make sure that they're doing well in there. And then once you're growing the fish in there, we need to make sure that they're being grown in a good environment. Now, we don't have standards for that environment, but we certainly, our goal is to be able to produce fish and keep them healthy and grow them and give them the right environmental conditions. And so we look at all kinds of things like the water quality, the water chemistry, and how to maintain that. Another thing that we're concerned about, and we've had a little bit of discussion about it in the Q&A, is drugs and chemotherapeutic options and what we need to do in terms of that. And then the best management practices for operating those systems. So if we look at water quality parameters, things like, you know, what are we going to look at? Make sure that those fish are in the right place. We're going to look at things like, how's the oxygen level? Are they in the right temperature? Is the salinity right? Those are the kinds of things that we're constantly testing for in these systems to make sure that we're providing the fish with what they need. Again, the farmer's goal is to keep the fish healthy and growing so that they can produce a high quality product. We also have to do chemistry, and this is a key area that we have to deal with within the filter systems, getting rid of those nitrogen byproducts which are bad for the fish and bad for the water culture environment. So we're testing for things like ammonia and nitrite and nitrate on a regular basis, the alkalinity of the system, the phosphorus levels. Here's an example of how you can maintain the right environment with a closed, 100% closed recycle system where we've got fish growth going up this way, but here is what's going on with my ammonia production thanks to the biofiltration setup that we have there, or nitrate concentrations, able to keep those down at the appropriate level for the fish just by using a range of different types of filters. The use of drugs and chemotherapeutics is a major concern. It's a major concern within the general population. There's a lot of misinformation out there about the use of that. In the United States, it's very strictly regulated by FDA, and withdrawal periods are required whenever things are used within those systems prior to harvesting. So we do not use those types of chemicals as background just to prevent anything from happening, but only under strict regulations that are in place. And with very limited inspection of imports, it's really important to consider the importance of U.S. produced product. In Florida, we regulate what's going on within our farming industry through best management practices, and they have been developed to both preserve the environment and to reduce duplications of environmental permitting requirements. So we have a one-stop permit system in Florida, but that's really not true. We actually have a second stop, and that's getting access to water. And water is the biggest limiting factor for expanding aquaculture in the state of Florida. Florida, where it rains for half the year, we have an extreme water shortage because we have a large population, and they want lots of water for everything: golf courses, swimming pools, drinking, everything you can think of. So it's just a matter of, do we want to have some of that food production going on in this country? Are we going to allocate some of those precious resources for that purpose? Then there's the water leaving the system, and the regulations associated with that, or the standards, will vary. In the United States, I am focusing on the U.S. because that's where we are, is going to depend on where that water's going. And so if it's going into state waters, it's regulated by a variety of different bodies. If it's small production, it may be regulated by the state. If it's larger production units, it's regulated by EPA. And there usually, if there's a large production system, there is a constant, ongoing water quality and environmental monitoring program associated with that. Okay, and then there's the processing portion. Now this is regulated, I think, all over the world, but certainly here in the U.S. it's very strictly regulated, and that's the HACCP system. And that is our system for ensuring that the seafood that's being processed is going to be handled in a way that is going to provide you with a clean product. And so there's a whole set of regulations associated with that. The HACCP standards require frequent testing, bi-weekly testing for certain things, weekly for others, and at least monthly for other factors. And so here's an example of a HACCP certified seafood processing plant at our facility where we're processing caviar. And you can see everybody's got their white coats and their hats and their masks, and you name it, it's all there. Completely sterile environment, boots, you name it, it's all in place. Before I leave, I want to leave aquaculture. I do want to spend a minute talking about, good, I'm on my, look at that, 1 minute and I got 2 left. So I want to talk a little bit about restoring fishery resources through stock enhancement, another really good tool that aquaculture can provide. It is a management option for restoring declining fish stocks. Certainly there's a whole range of different things we can do. We can reduce the harvest. We can develop marine protected areas. And another tool in the toolbox is to rebuild some of those species through the release of cultured fish. So here's Florida queen conch that are being used for restoration purposes in the Florida Keys. Also, it's done in many islands in the Caribbean. And here's snook, one of the hottest game fishes in the southeastern U.S. This is a hatchery fish that was released and then caught 5 years later. Oops, there's a few more. I forgot those pictures were there. Halibut, that work is being done up in the Pacific Northwest, and also Bocaccio, 2 other species that have been identified as fish that can benefit through enhancement. But the key is, if you're going to do it, you have to do that using a variety of different mechanisms to protect the wild fishery resources. So there was a paper written in 1995 by Blankenship and Lieber where they identified the types of things that you have to consider when you're going to use stock enhancement as a tool so that you do not damage that resource. And you are putting out something to help enhance it. So in conclusion, I knew this was an awful slide, and look, it really is. In conclusion, I just want to touch on my points from the presentation. The first is that fish is an important protein source. It's important for over 1 billion people as their primary protein source. 3 billion people are currently consuming it as a secondary protein source. We've got to have more and more fish available, and it's going to come from aquaculture. Our future seafood, since it's going to be supplied by aquaculture, needs to also have production going on here in the United States. And I thought I had one on here that said it was critical that it happen here in the U.S., but maybe that was somewhere else, and I've lost it on my slide. It is there. Okay, good. I'm glad to hear it. The production and safety regulations in this country ensure that U.S. seafood is safely produced. And our environmental sustainability is a growing priority in the U.S., but the key is, are we going to be willing to pay more for a product that's produced in a way that helps to sustain the environment? The hatcheries can be used also to rebuild fisheries, but only if it's done correctly. And shortages in food and water are constraining growth in terrestrial agriculture. So we know that this is going to happen on land and in deep water to produce the seafood that we need in the future. And the other area that's really becoming exciting and is moving into bigger and bigger activities is this multi-trophic production system development. Back to the past, learning from what we used to do, and moving on into the future. Thank you.